Hello guys, today we'll be solving problem 3 from homework 4. So right here I just went ahead and did the free body diagram just to speed things up. So first things first, it tells you part 1, determine the resultant of the 3 forces in pound force if M equals 115 pound inches. So this M right here equals 115 pound inches. First things first, we want to get the resultant force. So in this case, it's a 2D rigid body, so that we know there's only two directions, the y direction, x direction, there's no c direction. So we know that the sum of the forces on the x equals the resultant Rx. So in this case, it will be minus 40. We set up our positive going this direction. So this is case minus 40 plus 25 cosine of 60 degrees equals Rx. So if we further simplify, we get Rx equals 2 minus 27, 5 pounds. The sum of the forces on the y, that will give us Ry minus 10 plus 25 sine of 60 degrees. That will give us Ry, which in this case it's 11.6506 pounds. They ask you for the resultant, so in order to find the resultant, we can take the magnitude of these two. So we know our resultant equals Rx squared plus Ry squared, and then you take the square root. So then we get, plugging in the numbers, we get our resultant to be 29.9 pounds. So this is for part 1, very straightforward. For part 2 says locate the points where the line of action of the resultant intersects the line AB. So line AB, this line, AB, and line BC. So there will be a line of action for these. I go somewhere between these two. So first things first, we have to reduce the given forces and the couple to an equivalent force couple system. So this is how we will do it. So we can do the sum of the forces about B, because we want to get, when you take the moment, let's say that the moment from this force, there's a perpendicular distance with respect to this point. And if you take the force with this, the moment with this is perpendicular this way. So the point in order that you should take the point about should be B, because that will give you the perpendicular distance from here to whatever your resultant force in the X, and here to whatever resultant force on the Y, and then this on the X. So if we go, we say sum of the moments about B. That will be the resultant moment, and B, which then equals to, so this generates a moment. So M equals first M pound inch plus 40 times 8. So that's 120. Oh, pardon me. 4 times 8 is 32. So 320 pound times inches. Plus 10 times 12, so that's 120 inch. Oh, also don't forget to specify the direction. This is positive, so that's positive. 140, that's negative. It's negative. Plus 120, yep. So our resultant and B will be 120 plus 115. So it'll be minus 85. Minus 85. That will be our resultant moment at the point B. So now in order for this to be in equilibrium, we know that there's no moment generated at point B from this force because it goes in the line of action. So we know in order for this to be in equilibrium, we have to have the same moment going this way and this way. So we get MB should equal, there's a force that you already calculated a resultant force in the x direction and the y direction as well. So in the y direction, it's 11.65 somewhere in this line from A to B. And that will generate a moment depending on how far from point B it is. So we don't know that distance, which is what we're trying to find. So in this case, AY times A, which is the distance that we're trying to find. And then we do MB equals RX times B, which is the distance. So in this case, we gotta solve for A. So A will equals MB divided by RY. Okay. In this case, it will be, we plug in the numbers. It will be 7.3. Yeah, it will be 7.3. Let's just round it up. 7.3 inches. So this is the distance to the left of point B. And then we say B, so moment, Rx. If we plug in the numbers, this will be 3.09 inches. Let's change the colors so it's more visible. So these are the two points in the where line of action of the resultant intersects. So thank you guys for watching. That was problem 3, part 1 and 2.